So monitoring water quality is really vital for us as a Rivers Trust and for our partners and communities. It helps raise awareness and advocate for the issues in each different sub-catchment around the catchment, and we can inform those decisions on where to utilise money and resources to improve our rivers. So a lot of the time we don't know where a healthy river is and where an unhealthy river is, and if we don't know what's healthy, we don't know what to protect, and if we don't know what's unhealthy, we don't know where we need to restore. So monitoring across the catchment is really vital in giving us the right information to make an impact. So we utilise the results we find from River Guardians to help us in a few main ways. One is to detect pollution. Pollution can come from a variety of sources, from sewage, farm runoff and agriculture, highways and roads. There's so many sources. It's nice for us and really helpful for us to pinpoint where those sources could be coming from, impacting our rivers. Also, to help wildlife, we do a lot of monitoring of river invertebrates as well as chemical testing to provide quite a holistic view of the whole river health and how that impacts ecosystems and wildlife. And finally, to provide a long-term data set. Over a year, we can really start to understand the fluctuations and how things impact from weather and climate to different times of year for rainfall and sewage discharge. So it's really important to have that long-term trend to see how our data changes over time. When surveying as a River Guardian, it's really important we agree with WSRT and yourself a safe and accessible site. We'd love this to be publicly accessible, or your own land, and an area that you feel like there's not too many risks of slips, trips and falls, or an area you can put a bucket over a bridge or from a footpath. So basically it has to be accessible and safe for you to monitor all throughout the year. When surveying as a River Guardian, it's really important to wear protective gloves to keep you safe while out near water and rivers, as well as wearing sturdy boots or wellies to keep you safe on the riverbanks where you could slip, trip or fall. If you're sampling alone, it's really important that you let someone, your friends, your family know where you are and when you expect to return. It's ideal if you go out with a friend or family and they know exactly where you are, but if not, do let someone know using your What 3 Words location, a Google Maps pin or Life 360, or Find Your Friends so people can locate your last location. So the first thing when taking a River Guardian sample is to clean out your bucket. You can use any sort of bucket or sampling tool like an empty bottle, but the first thing we'll do is rinse it 2 to 3 times to make sure any residue from our previous samples is washed out. It's important when throwing a bucket in from a bridge or from a bank that you're in a secure and safe position, and if you're on a footbridge or a larger road bridge, that you throw the bucket downstream of the bridge so it doesn't flow underneath the bridge and get caught on something you can't see. So do make sure you're in a safe location to dunk your bucket with either a bit of rope or paracord or on a long pole. So now we're going to monitor phosphate. So phosphate is naturally occurring in our river systems but at very, very low levels. It's very often sourced from farm spraying, sewage treatment works, often from us as consumers, from the food we eat, to the washing detergents and dishwasher tablets that we use day to day. That passes through the sewer system and enters our rivers. If it's in too high quantities, it can cause algal blooms and eutrophication, which can cause a large green film on the top of our rivers that reduces biodiversity and can really impact the health of our rivers. So we'll be utilising this HANA phosphate checker to monitor the phosphate in the water. So it's a 2-step process using this HANA checker. First, we're going to use a test tube to calibrate or take a zeroing measurement of our site sample, and then we're going to add in a sachet of reagent, and it will then give us an accurate reading of the phosphate in the river. So the first thing I'm going to do is to put 10 millilitres of site water into this test tube. So we provide a 10 millilitre syringe, which will fill all the way up to the 10 millilitre line on the test tube. I'll then close the cap. I'll turn on our HANA checker. We've just got one button, so we just press that once to turn it on, and it will say Add C1, which is cuvette 1. I like to call it test tube, cuvette, same thing. So I'm going to pop this open and put our test tube inside. I'm just going to rub off any fingerprints or water droplets on the outside of this test tube and pop it directly into our HANA checker. Close the lid and just press the button once. So this is going to give us a zeroing calibration measurement So now it's asking us for C2. We're going to add a packet of reagent into this test tube. So I'm going to open up the Hannah checker and remove the test tube. The next step is to transfer this sachet of reagent powder into the test tube. This can be a little bit fiddly, and it's another reason why we're wearing our gloves today, because it's not a naturally occurring chemical in the environment. So what I'm going to do, I'm just going to flick this sachet to get all the powder to the bottom corner. I'm then going to cut along the scissor cutting guide along the edge, and I'm just going to funnel it straight into the test tube. So I'm going to now create a funnel. Oh, bad cut today. So I've now created a short funnel, and I'm going to pour this into our test tube. And you can just see the reagent falling into the test tube. The last thing that we do before we get our sample result is to just invert the test tube until all the powder is dissolved. So with this, I'm just going to utilise my warmth of my palm. I'm just going to slowly invert this until all of the powder is dissolved. So all of our reagent powder is dissolved. So the last thing I'm going to do before we get a result is just wipe off any excess fingerprints or water droplets on the outside of the test tube. I'm then going to put this back inside the Hannah checker, close the lid, and this time I'm going to hold the button until it gives us a 3-minute countdown. So it's now given us a 3-minute countdown. I can pop this down on the floor and get on with some of our other equipment tests today. So our 3-minute timer is almost up. When it gets to 0, it will calculate its value and give us the result of phosphate. And today it's given us 0.66 parts per million, which is quite elevated today on the river store, which is not always ideal to see. So with this result, I'm going to upload it directly to Cartographer, our sort of central database with all of our water quality data. The last thing to do before moving on to our next test is to dispose of this site water that has this reagent in it. Because this reagent is not a natural chemical found in our river system, we want to practice what we preach and dispose of it safely. So we recommend bringing along some toilet roll, pouring your today's test tube inside the toilet roll, capture as much as you can, and then just have to pop it in a Ziploc bag that you can use as a bin bag and dispose of safely in the general waste. Next test in our River Guardian survey is looking at nitrate. So nitrate, again, is common at very low levels in our river system, but mostly is sourced from fertiliser and farm spraying, and that running off after big rainfall events. Too much nitrate in our rivers can be detrimental, similarly to phosphate, because too much of it in our river systems can lead to algal growth and eutrophication, hindering the biodiversity in and around our rivers. So today, to monitor nitrate, we're using these hatch test strips. These are quite simple, and you might have used something before at school or at work. All we have to do with this dipstick is dip in our river sample for 1 second, count to 30, and then compare with our colour grading chart. So I'm going to dip for 1 second in our river sample. I'll remove, and I'm going to count to 30 seconds. So it's now been 30 seconds, so I'm going to compare our nitrate, the square at the end of our dipstick, to our colour chart. To me that looks like 10 parts per million. The importance of monitoring or measuring after those 30 seconds is that this dipstick colour will continue to darken over time. So if I left it on the side for an hour and came back, it would probably be the darkest it can go. So 1 second of dipping and then 30 seconds before comparing with the colour chart is really important. So next we're going to be measuring total dissolved solids. So total dissolved solids is the sort of accumulation of both organic and inorganic matter that's dissolved within the river system. That can be things such as salts, soaps, chemicals, rubber, anything that can often run off our roads after a heavy rain event that's then dissolved in the water. So there's a very simple way of measuring this with our TDS sensor. We have 3 buttons: on, off, temperature and hold. All we're going to do is take off the cap, turn the sensor on. I'm then going to submerge this in our river sample. I will then wait for the reading to stabilise, and when that reading stabilises, I'm going to press the hold button, and when I remove it from the sample, it will give me our result. Today it's 300 parts per million. So it's important to remember that this TDS sensor is not completely waterproof, and we recommend only dunking until this sort of lower ridge at the bottom. So that's an inch or 2 into the water. And then we also have the temperature button. If we press temperature just once, it will switch over to our temperature reading, and today the river store is recording at 16.9 degrees Celsius. If we press this again, this will go to Fahrenheit. You can ignore this, and if you press one more time, it will take us back to total dissolved solids again. So you can press total dissolved solids, temperature in Celsius, temperature in Fahrenheit, and then back to TDS. After this, you can turn off the sensor, shake off any excess water, put the cap back on, and record to cartographer. So it's really important we monitor temperature of our rivers, because it obviously changes across the year, across the seasons, and it's important for us to track this based on climate changes year on year. It affects the oxygen content for things that live in the river, and it's a really important thing for us to track as we go across the year. So our final test is looking at turbidity. This is the clarity of the water and how clear or murky it is. It's really important because if a river is brown and murky and muddy, it's often not good for fish or invertebrates that live on the stones on the bed of the river. So a clearer river is often better for wildlife. We're monitoring this using a turbidity tube. We're going to fill this up bit by bit with our river sample until we lose sight of this X on the bottom of the tube. So we'll fill up bit by bit and check every now and then by looking down our turbidity tube until we lose sight of this X at the bottom of the tube. So now I'm going to fill in with our sample water from the river store today. So I've filled up slightly. I'm just going to look down. Still very clear. I can see the X at the bottom of the tube, so I'm going to continue to fill. And actually I filled the tube all the way to the top, and I can still see the X at the bottom. So that's fantastically clear. I'm going to record this as 5 JTU, which is Jackson Turbidity Units. So collecting this water quality and river health data is really important for our River Guardians project. We've been sampling now since January 2024, and this information is crucial for us as a Rivers Trust, but also to communities and to our partners into where the issues are. In some areas we've got really big issues of turbidity and sediment entering the river, others nutrients like phosphate and nitrate coming from farm runoff or from sewage tanks, or septic tanks and sewage treatment works. Across 2024 we had over 1,000 surveys, and we accumulated this into a simple 2-page river scorecard for each of our water bodies or sub-catchments across our catchment. This has been fantastic for advocating and raising awareness of the local issues. So here at the store we've had issues with phosphate input and sewage treatment works, and across other areas of our catchment we face different issues like habitat, invertebrates and lots of invasive non-native species. So thanks for listening to this River Guardians tutorial. If you are in need of any support at all, please do get in contact with WSRT on our Contact Us page. On our River Guardians page we've got a support and FAQs link if you have any questions on how to do the sampling or what to do with the data. So we upload all of our data to Cartographer. You'll receive a login for this from a WSRT staff member, and you'll be all set up to start safely monitoring and uploading the data from your local river to benefit not just WSRT but your local community and all the river users.